So let's take a look at the next part, angle of friction here. In our problem, that in our analysis here, that we talk about the normal force here and the friction force here, and sorry, I should draw it here. I should draw it below here. And the friction, I draw it here. This is P, and this is F, and this is N. So please draw it in the on the bottom right hand corner. Now, and we know that, and we know our curve, right? We know this curve. After we have this, do you remember what is what's the quantity here? F. And how about that one? P. Here, and we have the maximum is mu s times n, and this one is mu k times n. So remember the shape of this curve. This is mu s times n, and this mu k times n. Remember the y-axis is m and x-axis is t. So in our study, in our notes, that it looks like the friction F is related to N. F is closely related to N here. F is equal to mu s times N or equal to mu k times N. Therefore, because both of them are acting on the contact surface. Both of them are acting on the contact surface. Therefore, we will combine these two. We will put these two together and say this is R. And this is the angle here is called angle of friction. Combine or we add them together. I think the better translation of combine is to but here you can mean helping. So we put N and M together, and we have R here, and we have this angle called angle of friction. So, is that okay? Here we look at three cases. Here it means so let's have if we have the P, which is not very, the
force P here is not very large. That means it has no motion. In this no motion, the R, let's draw it in the way I've talked until now, that N and F here. Here, the friction force F is smaller than mu S times N, right? Here, force is smaller than mu S times N, so it has no motion. It's on this point. It's on this point. So for the angle, phi is smaller than phi S. So the angle is smaller than phi S. If the friction force is reaching this point, what's this point called? This point is called motion impending. That means F is equal to mu S times N. So we say the angle is equal to phi is equal to phi S. Because remember F is here and N is here. So F is equal to mu S times N. And if the horizontal force P here is very large, it starts to have motion, that F is equal to mu K times N. And N is here. And the angle is equal to phi K. So you can say this phi S and phi K as just saying the same thing again, that phi S is correspond to mu S, and phi K is correspond to mu K. Correspond to means correspond to do you know what does it mean, correspond to? So we say mu S correspond to phi S, and mu K correspond to mu phi K. But so they're actually you can say they are actually the same thing. But in one case that it is quite useful. Let's have a look. So assume we have a block here. W, base W, and it lies on an in Chinese, of course, we say this is 斜平面. What do we call this? How do we call this in English in problem 8.1? How do we call this in problem 8.1 on the last page? It is called 平面是 plane. 斜. Let's look at the page. Let's look at sample problem 8.1. How do we say it? Inclined plane. Okay. Inclined plane. So here we have an inclined plane. We have an inclined plane. Take a look at this page 63. Page 63. Now, as in sample problem 8.1, we have this. We have R here. We have R here and we have F here, because without because without a force here, the block will go down. The block will slide downward, so we have a friction force going up. Okay. If we don't have this one, then it will go down, right? It will go down, and so the friction force is going up. And the slope of the incline theta this is theta is slope, or sorry, we can say yeah. If theta is very small, if theta is very if theta is very small, there is no motion. In this case, let's draw the free body line. Let's draw the equilibrium. Let's draw the forces and to determine the equilibrium. Here, W is going downward, and we have reaction force, support force here going to R is going this way. And remember this one. What's this angle? This angle is theta. Because it has no motion, that F is going to the right. Sorry, F is going to the right, going up like this. So this one is the angle of this one is also theta. This one is right angle. So in this case, because the theta is small, that we can say theta is smaller than phi s. So wait a minute. Should I draw it? Let me draw it a bit better. I think it should be maybe here and look like this. So because there is no motion, summation F is equal to 0. So these three forces should, so R plus F is equal to minus W. And there is a relationship between R and F because it is because F is equal to mu times R, but in this case we haven't reached this mu s yet. We have a very small value here. So here theta is smaller than phi s. Phi s is this one, or you will say, or I will say in an easier way. F is smaller than, or simply, or put in another way, F is smaller than mu s times n. Because the angle is very small, that we don't need a small we have a small fraction. So this fraction is smaller than mu s times n. Now if it's okay. So in this case, because we have a small angle of incline, so we have a small angle of incline that it only has small angle that it will not go down, right? If the angle is going larger and larger, then it's going to slide down here, right? So if the angle is small, then it stays there and there is equilibrium. So in equilibrium, R plus F is equal to minus W, and here the friction force is more than the maximum value, smaller than mu s times n. Now, if we increase the angle, if we increase the angle here and here, and it reaches motion impending. And for this theta angle, motion impending, of course, we still have R and F here. Oh, sorry, I will say N. Sorry, I should say N here. Please correct this. This should be N, and this is also N, and this is F. So this is the case where the slope is very high, and if it is higher, then it will slide down. But it's still at rest. This is still in equilibrium. So in this case, W is here. R is here. F is here. F is here. And we still have this relationship. Because there is no motion, we still have R plus F is equal to minus W. But if we say, of course, this one is theta and this one is theta. But if there is motion impending, that is it reaches maximum friction. What do we know about? I'm sorry, this should be N. These two should be N. Let me correct this. What do we know about the relationship between F and N? If it is motion impending or there is maximum friction. If we have maximum friction, what do we know about the relationship between F and N? If F is maximum, F is equal to what? Let's look at the figure again. That is, if the friction is at maximum, so it is F is equal to mu s times n. So here it is equal to mu s. So if F is equal to mu S times N, so what is theta? We know F is equal to mu S. This one is mu S times N, and this is mu N. This is mu S times N, and this is N. So this angle theta is equal to arctangent of what? Arctangent of mu S times N over N is equal to arctangent of mu S. And we did in this on this page we call this angle of friction is phi S. So this angle that it is still at rest, but it is motion impending. This angle theta is related to is equal to tangent arctangent of mu S. So the concept of angle of friction is actually just another way of saying frictions here. But if we have this angle of friction here, then it is easier to say, oh, now we have if we know the angle of friction, it means that we have if the slope is higher than mu S, then we will have motion. But if the angle theta is smaller than phi S, we have no motion. It has another use as well that I will talk about it on Tuesday. And on Tuesday we will talk about I will talk about wedges. Wedges is like if we put a force here, that it will push to the right, and block A will go up. But after we remove the force P, that it is at rest, it will be in equilibrium. We call it freestanding. Because this one will not go to the left and this one will not fall. So it will stay at rest. It will be in equilibrium. It's called freestanding. So I will talk about this on Tuesday.